Hi everybody, hope everything is going well for you. Let's get started on some vectors. So you have the definition of a vector right there. The important part is that you know there are two things to a vector, the magnitude and the direction. We'll get into direction and the details of direction in the next couple lessons. Today we're just going to focus on kind of an overview, how to draw them, and really we're going to deal with mostly the magnitude. So some important things, and they have it written there, but just to kind of go back through what's here. When you go to give a vector a name, you want to make sure you use a lowercase letter. So the name of a vector is any lowercase letter, and then above the vector name you put kind of a half array. That is the vector symbol, so be sure to use that. Now in terms of the magnitude, when you go to indicate magnitude, and it's right here, just to reiterate this, you want to use absolute value bars, the name of your vector inside, and that would be the magnitude. Now for magnitude, it's really just the distance. It's just really the square root of the Pythagorean theorem. So it's really just the answer that you would get for the Pythagorean theorem. And that's what we're going to look at mostly today. So the direction will come from some angles, mostly tangent, and we'll get into that eventually. So take a look down here at the bottom, and if you've never drawn a vector either on ALEX or any other class before, the vector has two parts. It has a tail and it has a head. So I'm just going to draw one. The tail is the end point, and the head is like an arrowhead. So the arrow is the head. Also, there's a couple ways that you're going to see the vector written. Sometimes you're just given the coordinates like you are here in part A. Other times you are going to be given these weird looking pointy brackets. This is component form. And we're going to go through some examples here of the difference between the points that you're given and then, of course, component form. Also, we're going to go through some definitions. I just think it's easier if you actually see the definition in working rather than just sort of read the definitions. So for this first part, part A, we're going to draw this vector on, try these A. We're going to draw this vector on this coordinate plane over here to the right. This first one is component form. Component form is basically giving you the coordinates of the head. Standard position means that the tail is at the point 0, 0. So we're going to start at 0, 0. That's where our tail would be. And then, of course, we're going to put the head at 2, negative 5. So I'm just going to put a point there. So that's not really going to be a point. So here is the tail. Here is the head. And this is, of course, vector V. And that's how you would name it. Now, for part B, those are the endpoints. Those are the actual coordinates. So you got to pay attention to the way the brackets are written. And when you write them yourself, you also have to make sure that you're very clear in your communication. So if we have the tail at negative 4, negative 2, and we have the head at negative 2, negative 2, it's going to go this way. So it's just that little guy. And this is, of course, vector U. Now, from part C, we have a combination. So this is the difference between the point and the coordinate and the component form. So the component form is like how you would count. Obviously, positive numbers are to the right or up, depending if they're X or Y. Negative numbers are to the left or down, depending, again, X or Y. So the tail is at negative 1, 2. This is basically where we're going to start. So negative 1, 2. So right there, that's where we would start this thing. And then the components are 3, 3. So that means 3 positive, which is 3 to the right, and 3 to the right, and then 3 positive again, which is 3 up. So 3 to the right and 3 up. And then this is where the head will be. And then this, of course, is vector T. So that's what it looks like on a picture. We take a look at this thing just with some values. So now we're going to actually read the picture, if that makes sense. I'm going to just jump right to part B. You can read the directions up there on your own if you care to. So it says determine if a pair of vectors are equal. Vectors are equal if they have the same components. So we have to get this thing into component form. So vectors, vectors are equal if components are the same. So we need to put this thing in component form. Component form is very, very particular. Component form, and all this is written up above there, if you'd rather read their words instead of mine. Component form is head minus tail, very specifically in that order. You do x's to x's, and then you would do y's to y's, and you would write it in component form. So let's try one here. So for part A, it says determine whether each pair of vectors are equal. Support your answers. The support of your answers really is going to be your component form and your work. So I'm going to try to put all this, I'm going to put all this together kind of in one. So vector V, and we can read vector V off the picture. So vector V is this guy right here. I didn't realize I was going to end up writing on top of that. I thought it was a highlighter. But now you can hopefully see vector V a little bit better. We can still see the number, sorry about that. You obviously have it on your picture. So for vector V, I'm going to do x's first, all right, because that's the component form. Component form is x first. So for vector V, let me put this back into black here. So I'm going to have -6 minus a +2. And then for the y's, I'm going to have -2. You have to go in the same order. I went, you got to go head minus tail, -2 minus a -8. So those are positive. And so our component form for vector V is going to be -8, 6. Now our component form for vector U, I'm going to put this up here just because I'm writing kind of big, sorry. So for vector U, again, head minus tail, arrow minus point. And so vector U is the one in the second quadrant, and of course its tail is at 0, 0. So we have -8 minus 0, probably unnecessary, but I want to go through this carefully. And then for the y's, 6 minus 0. So vector U has component form -8, 6. So yes, these components are equal. These vectors are equal. Let's do another one, just in case this one isn't matched. So for vector U, we already know vector U. Vector U, give it a name, component form, be very specific in your notation, -8, 6. So we already know that. Now for vector T, oops, that's supposed to be over that. Head minus tail. So for vector T, x first, head minus tail. 2 minus 8, which this is unnecessary. If you can do the arithmetic, just do it. I just am trying to be slow. And then 8 minus 2. And so for vector T, we get -6, 6. And so they do not match, so no, these two things are not equal. For part C here, it says write the component form for a vector with our tail at -8, 6 and the head at 12, -15. This is the same thing as we just did. I just want to go back through this and show you, maybe not from a picture, just to give it a little different idea. You have to pay attention. Which one is the head? So make sure the head comes first. So 12 minus -8, x's together, and then do the y's, -15 minus 6. And so then we would end up with our vector components being 20 and then -21. Now, I skipped all this in the beginning. They're going to refer to this robotic arm, and with our vectors, it's kind of the theme for the vector section for the next couple days, the next couple sections. They're going to constantly talk about this robotic arm or our robotic hand and how it moves. So I know I skipped it, but let's take a look at this problem because they're going to go back to referring to it. It says, let vector v be the vector that describes the change in position of the robotic hand. What is the component form of vector v? What does the component form indicate in this situation? So I know this is all the way back on the first page. I'm just going to summarize what we were told on this first page. I know that we skipped it. So basically what it says is the robotic arm starts at 5120, and they sort of superimpose the robotic arm on a coordinate plane, and it ends at 9865. So you got to think about what that means in terms of head versus tail. So when you're drawing a vector, this is where it starts at the tail, and it ends at the head. So remember, you're going to go head minus tail. You're going to go end minus beginning. So it's worded a little bit differently. It's the exact same process. We're still subtracting, but now we're putting it into a little bit more of a real life sort of application. So those are still the numbers, and let's answer the question. What's the component form of vector v? Okay, so now we maybe know what to do a little bit better. So vector v, we want to go head minus tail. So 98 minus 50. And then we're going to do 65 minus 120. And so we end up with the component form of this vector being 48 and negative 55. And so then the question says, what does this really mean in this situation? This was measured in centimeters. Again, I know we didn't go through it, so let's make it make some sense. So the final position, or ending position of the hand, the robotic hand, is 48 centimeters to the right and 55 centimeters negative down. So don't put the negative. Make sure you write the word down. I know those of you in physics are super used to this, and if you're not in physics, no problem. That's why we're kind of starting at the very, very beginning. We will go through this slowly. And this is from the initial position. Do not assume that the initial position is the origin. Right? We don't really know. Now, finally, we're going to get into some magnitude. I know we talked about it in the beginning, and we haven't really done it yet. Remember, magnitude is the square root of a squared plus b squared. Component form is written ab. So you use component form, not the coordinates. Use the components. So when you're asked for magnitude, use components. And so I'm going to come down here. The name of the vector was vector v, so the symbol is absolute value. Put the name inside. We're going to do the square root of 48 squared plus 55 squared. The negative, when you square it, it's gone. So if you're going to not type this in correctly, if you're going to use your calculator and be lazy with your parentheses, drop the negative. Put this in the calculator, and we actually end up with a whole number of 73. And so the magnitude of this thing is 73 centimeters, sorry. So that obviously the length of its movement, the component, so the left, right, up, down would be the one we just answered. So 48 to the right and 55 centimeters down, whereas the magnitude is like the hypotenuse, the straight line distance. So if we were just to go directly there, the straight line distance would be 73 centimeters. Your assignment is right here, and let's leave this here if you need to take a quick screenshot of it. Your assignment's right there. We're going to do 6 through 10. Sorry about my wiggle. 6 through 10 right here. If you have the paper, just do it right on the paper. And I'll post the next video tomorrow. I hope everyone's doing okay. And try to do something fun every day. Try to do something nice every day. Have a good one.